Dana, when Ross is on your call, the chairman of the board of CCL. Okay, thank you everybody for joining us. The discussion tonight will be impact. So the impacts of climate change. A little bit of background from me, and then I'm going to hand it off to Dana. So every year, or every 7 years, I think it is, when the IPCC does a report on climate change, the comprehensive assessment reports, there's 3 sections. The first is on the climate science. The second is on impacts. What does it mean? What's going to happen? And then the third is on the economics and solutions and the such. So this is that middle topic, if you will. Why is it important to us? At CCL, we're a bit unique. We recognize fully that in talking to people as we do, we're the presenters, and you just give them the problem. We've seen the science, they walk away discouraged, disempowered, they go numb to it. They can't hear about it. They can't really take it in. So CCL is very solution focused, but we got a bit of a quandary here, and we're going to tackle that tonight. And the quandary is probably people in the country don't fully appreciate the gravity of the threat that climate change presents to themselves and to their children, okay? So we got to help them get it. We got to help them get it in such a way that it doesn't turn them off, and we're going to follow that with the solution that we feel is commonly agreed, simple, fair, and increasingly popular. So that's what tonight's about, having people have a sense of the gravity of the situation. For that, perfect guy for us, Dana Nusatelli. Dana spoke on our national call. It was years ago. I remember where I was, but about 4 or 5 years ago. He's an environmental scientist who writes about climate change for The Guardian and for the blog Skeptical Science. I believe he is one of the co-founders of that blog. He's published 10 peer-reviewed papers on climate change and has authored a book called Climatology versus Pseudoscience. So Dana will be speaking about the research on the impacts of climate change, including things like intensifying extreme weather events, slowing economic growth, or the impact on economic growth, and at least a little bit about a very current topic, Harvey, and the degree to which we can tie that, or how we might tie that to climate change. Okay, that's it for me. Dana, thank you so much for all that you've done for CCL over the years and for this presentation now.
Thanks, Jerry.
You got it.
Can everybody see my screen at this point?
I'll take that as a yes. They're nodding yes.
Okay. All right, then let's get into it. Let's try to get into it. Okay. So I just wanted to give a little bit of background on myself in the first slide, just so people don't wonder who I am the whole time when I'm talking. So I have backgrounds in physics, and then I sort of shifted into environmental science. And then I spent a few years learning about climate science, just reading stuff on my own. Eventually I learned enough to start writing for skepticalscience.com. I did that for a few years, and then The Guardian hired me on as part of their international environmental blogging network. So I've been writing for The Guardian for a little over 4 years now. And as Jerry said, I've written some peer-reviewed climate papers in my spare time. And I'm a member of the Sacramento chapter of CCL. And then I also wrote this book, Climatology versus Pseudoscience. So I always have to plug the book because it's really hard to get people to buy your book. And so you can buy my book on Amazon if you're interested in learning more about various stuff that I like to talk about. Okay, so impacts. So when we get global warming, we get rises in temperatures, and that causes various types of climate change, which results in various different types of impacts. And so a few examples of that is that when we get higher temperatures, we get warmer oceans. And when you get a hurricane going across warmer ocean waters, that basically fuels the hurricane and makes the hurricane stronger and makes it intensify faster. And so then you get the bigger impacts from hurricanes. So it's basically climate change puts the hurricanes on steroids on average. and I'll talk about that more when we get to Harvey. Another direct impact is when global temperatures rise, it causes ice to melt, land ice. When the land ice melts, it goes to the ocean, causes sea level rise, and also when water warms, it expands. That also causes sea level rise. And so when you get a hurricane going across an ocean with higher sea levels, that creates bigger storm surges. That's another way climate change impacts hurricanes and hurricane impacts. And of course, when you have higher temperatures, you're going to get more frequent and stronger heat waves. And you're also going to get bigger wildfires when temperatures are higher, and I'll go more into that in a bit. And when you have higher temperatures, you also get more evaporation, which means you have drier soil. So that basically tends to intensify droughts. And you also have, when the atmosphere is warmer, it's able to hold more water vapor. And that means when you have an intense precipitation event, that amplifies the intensity of that precipitation event. So again, that's another way that climate change impacts storms and events like Harvey, which I will get into now. So obviously we have to talk about Harvey because that's kind of the big news story going on right now. So those are sort of the three ways that climate change amplified the impacts of Harvey. As I mentioned, we have higher sea level, which means the hurricane going across the Gulf of Mexico basically pushes a bigger storm surge onto land, and so you get more flooding for that reason. And the ocean waters, or the waters in the Gulf of Mexico, have been particularly hot. One of the reasons is because global warming is warming the oceans, warming the Gulf of Mexico, and so hurricanes going across those warmer oceans become stronger. And then the third way, as I mentioned, you have more water vapor in the atmosphere, and so at least when you have extreme precipitation events, that appears to make the precipitation events that much more extreme, that much more rainfall. So you have those three factors all combining to make the impacts of hurricanes like Harvey more intense, and really that applies to all hurricanes in general. You can make the same general comments about Hurricane Sandy, Hurricane Katrina. In each case, you have sea level rise due to global warming, you have warmer ocean waters due to global warming, and you have warm water vapor in the atmosphere due to global warming. And so all those human-caused factors amplify the effects of these hurricanes. I think it's worth spending a moment talking about how to communicate about hurricanes. Because I'm reading a lot of articles about Hurricane Harvey. A lot of them have up front, they say something along the lines of, we can't say global warming caused Hurricane Harvey. And that's really the wrong way to frame communication of a hurricane, or really any kind of extreme weather event. You don't want to focus on, here's what we can't say. You want to focus on, here's what we can say. What we can say is, we have higher sea level, we have warmer oceans, we have warm water vapor in the atmosphere. These are the things we can say are caused by human-caused global warming that are making the impacts of these hurricanes more severe. And then at that point, once you establish what we do know, then if you really want to, you can say, well, we can't say Hurricane Harvey was caused by climate change because it wasn't. Hurricane Harvey would have happened with or without climate change. That's really the wrong question to be asking, and it's really the wrong point to be focusing on. Because if you focus on what we don't know, and then it kind of firms up in people's minds, oh, we don't really know what's going on with climate change and Harvey. So it's really important to lead with what we do know. So I think that's an important point, especially for presenters, an important point to focus on the connections that we can make between climate change and these kinds of extreme weather events. So sea level rise, not only is our sea level is rising, but that rise is accelerating. And so this is a nice chart of sea level over the past 140 years or so. And so you can see basically it was rising slowly, and then it started rising faster, and it's rising faster yet. And then we can look at projections into the future, and it continues rising faster and faster. And so there's sort of a range of possible sea level rises that we can see over the next century. We don't expect to see much more than 2 meters or 6 feet by 2100. It's definitely, this slide says that's the highest. It's possible that it could be higher. Sea level rise is something that's really hard to project in the future, mainly because of ice sheets, because we have a really hard time predicting how fast ice sheets are going to collapse. They're very dynamic, and it's not something we have a very good grasp on, because frankly, past climate changes weren't that fast. And so, we know over, thousands of years, temperature rose a few degrees, and over those thousands of years, sea level rose X amount. But we're not talking about thousands of years, now we're talking about hundreds of years or even decades. And so it's very hard for us to make an analogous, comparison between today and past climate changes. And so our best guess is that we're probably looking at no more than 1 meter or 2 of sea level rise by 2100. But again, it's a really hard thing to predict. And of course, the less global warming we see, the less sea level rise we'll see. So I've got a few slides looking at how that sea level rise will impact specific regions. And since I live in California, a lot of my slides tend to focus a little bit on California because that's what I do my presentations about. And so the first one I've got is about California, the Bay Area, and the Central Valley. This is what it looks like right now. And then if we were to have a 2.5 meter sea level rise, which is sort of towards the top of what we might see by 2100 or a little bit after that, that looks like that. And so the green is sort of areas that are protected by levees and man-made obstructions that are preventing flooding from happening. But you can see there's a lot of flooding, especially in the Central Valley because of the delta water coming in from the bay to the delta and flooding a lot of the Central Valley of around Sacramento area where I live. And so I think this is a kind of a useful thing to show in presentations if you live sort of near a coast or an area that's prone to flooding, because it sort of hammers home that this is an impact that we're going to see in the relatively near future. It's something that's going to impact us, soon, if not now. And so I think one problem with climate change is people view it as sort of a distant problem that's not going to affect them. It's going to affect other people in the future, and it's not something that they think is an urgent problem. And so if you show them, well, here's what sea level is going to look like in the next 100 years or so, it's going to affect, maybe your children or grandchildren, that sort of hammers home, wow, this is really an urgent problem that we need to address so that this doesn't happen. So I've got a few other ones. This is around Louisiana, New Orleans area. This is what it looks like now, and then 2.5 meters of sea level rise. It looks like that. And so, New Orleans, they've got a lot of human engineering trying to protect the city, but there's a lot of areas in southern Louisiana that get very, very flooded. And another good example of that is South Florida, around the Miami area. This is what it looks like now. And then under 2.5 meters sea level rise, again, you have a lot of human engineering trying to protect areas from that flooding, but a lot of South Florida ends up underwater. So I mentioned trying to make historical comparisons, and so that is still a useful thing to do. One really good one, it's called the Mid-Pliocene era, which was about 3 million years ago. So at that time, it was a pretty similar climate to where we're at now, where we're headed the next century or so. At that time, global temperatures were about 2 to 3 degrees above pre-industrial levels, which is sort of basically our Paris target is 2 degrees. So that's sort of where we're headed, is in that 2 to 3 degree range above pre-industrial levels. And carbon dioxide in the atmosphere is around 400 parts per million, which is right about where we are today. So it's a good analogy because it's a similar climate to where we are now, where we're headed in the next couple of decades.
Hey, Dana, let me put you on hold real quick. We got a chat that some people, anyway, have not been able to see the last 4 slides.
Oh.
If you could just send me a quick note, and it's clearly I'm seeing them and many others are as well. If you could just send me a quick note or jump on chat, let me know. I want to get a sense of how many people. Okay, good. Sounds like we're good now.
Okay.
And the suggestion is to try restarting Zoom. You're on a roll, Dana. Keep going.
Yeah, also there's a link to Dana's slides in the email announcement that we sent out earlier.
Yes.
You can follow that way. Great.
Yes. Okay. So Mid-Pliocene, similar climate to today in the next century or so. And so based on historical research, scientists have estimated that the West Antarctic ice sheet collapsed around when temperatures were about 3 degrees above pre-industrial temperatures. So that kind of gives us an idea when we can expect to see some of these ice sheets collapsing. And we're kind of already on the way there, in the process of several ice sheets are in really bad shape right now. So it kind of gives us an idea we're kind of in that range, getting close to the point where we have to worry about ice sheets collapsing. And so what's really concerning is that at that time, global sea level was much higher than it is today. It's somewhere in the range of 15 to 25 meters, which is 50 to 80 feet higher than today, at a time when the climate was pretty similar to what it was today. So that, that kind of gets to the point that, at that time, in the Mid-Pliocene era, the climate change was, it's similar to today, but it happened over a much longer period of time. And so basically it takes time for these ice sheets to melt. But that kind of tells us, like, even in the climate we're at right now, eventually those ice sheets are probably going to melt, and we're eventually probably going to see a lot of sea level rise. And so it's something that, basically it's something that we have to realize we've kind of already committed ourselves to a lot of sea level rise. Hopefully it will happen relatively slowly so we can try to adapt to it. But, that's just something, it's kind of a statistic that I think will hit home for a lot of people, that at a similar climate in the past, we had so much higher sea level that, we can expect to see serious impacts even from the climate change that we've already caused, or the climate change that we'll see in the next century or so.
Hey, Dana, let me stop you for a moment and see if we've got some questions. So what we'll do is we'll take questions intermittently, and this is maybe a good time. Go ahead and just unmute yourself and go ahead and pose any question to Dana. Let me start off. I've got one. One of the things, you definitely hit the big three with respect to how climate change is impacting what hurricanes will look like. One of the other things that I see mentioned, which it sounds like they cannot state with any certainty, is this phenomena where, because the poles are warming so much quicker than the equatorial or the tropics, storms seem to be stalling a bit.
Right.
And maybe something. What can you tell us about that and what we might be able to comfortably say about it?
Yeah, I'm glad you brought that up. I had meant to say something about that. So basically, the way that we're changing the climate, it seems to cause more atmospheric patterns where weather patterns get stalled. They kind of get stuck in one place, which is kind of what seemed to happen with Hurricane Harvey. It basically got stuck right off the coast of Texas, and so there was a lot of rain and precipitation, wind, and all these things kind of pummeling the coast of Texas because it was stuck there for a long period of time. So basically what we can say is that is sort of consistent with what we expect to see more often in a warmer world based on current research or the most recent research. It's definitely not something we can say for sure humans are impacting the jet stream and these atmospheric circulations, and that caused Hurricane Harvey to stall in place. That's definitely a step too far.
Yep.
Basically, so what we can say is it seems from the latest research, the kind of stalling pattern based on changes in atmospheric circulations that happened with Harvey is something that we can expect to see, most likely expect to see more often. But that's definitely sort of cutting edge, relatively tenuous science that climate scientists aren't in consensus about yet. So that's definitely something that you wouldn't want to focus on. It's something that you can maybe bring up, like maybe this is another way humans are impacting hurricanes. But I mean, I personally think the other three are like really solid, and it's already 3 different ways that humans are impacting hurricanes that I think it's better to focus on those. And once you start talking about jet streams and atmospheric circulation patterns, you're kind of getting into the weeds, and you might tend to lose your audience a little bit.
Gotcha. Okay, thanks. Other questions?
Dana, this is Bruce.
Hi.
I'm still a little bit fuzzy on why the polar regions are warming so much faster than the rest of the Earth.
Yeah, so that's a factor called polar amplification. The main reason being that the poles have a lot of ice, and ice is very reflective. And so basically you get sunlight bouncing off of ice, but then once the ice melts, then instead of reflective ice, you have a dark ocean. And so instead of reflecting off of ice, you get sunlight being absorbed by the dark ocean. And so then you get this feedback effect where you get a less reflective Arctic means absorbing more sunlight, which means getting hotter, which means more ice is melting, and more ice is melting means that it's less reflective and it absorbs more heat, which means more ice melts, and you get this sort of this feedback pattern.
Right. So it's all due to that loss of the albedo effect.
Right, exactly. That's the main factor. It's definitely, yeah. And so it's actually something that was predicted a long time ago. I forget how early it was predicted. I think there was one paper in the 60s that predicted that effect would happen. And so it's something that climate scientists have expected to see, and it's something that they've predicted correctly.
Thank you.
Mm-hmm.
This is Larry Kramer.
Jerry, there's a number of questions in the chat as well.
Yes.
Go ahead. Go ahead, Larry.
Yeah, the Harvey was very slow moving, and where it initially hit in Rockport, there were high winds, but in Houston, there was no storm surge, there was no high winds, but the Gulf of Mexico has been heating so much that the coral reefs off the coast of Texas and Louisiana, last October, the National Park Service noticed that about 50% of them had died because of the warming of the Gulf of Mexico. And so Harvey just sat off of South Texas and just pumped water out of the ocean and dumped it on the land. And that's why they got so much rain, not because of storm surge or wind.
Okay. Well, certainly there's a lot more precipitation is one of the key points that Dana make. There's just a lot more water vapor in the atmosphere. We can measure that. We know rain events are going to be much stronger. But yeah, clear the stalling may have had a very big impact as well. Dana, anything else you want to say about that?
No, I think you pretty much covered it. Yeah, I mean, the fact that it stalled off the coast and there was a lot of precipitation, I think it's measured in the trillions of gallons of water was the amount of precipitation that coastline got, or the entire area. So it was a pretty amazing amount of rain.
Yeah. Yeah. Another question from Dee's is, the 50 to 80 feet, should we be cautious about that? Because it may be one of those sort of extreme scenarios. And I think your point was, it's not so much as extreme as it would take a long time, possibly hundreds of years to manifest itself. And so we may want to steer clear of that. But what are your thoughts?
Yeah, I mean, my point is just that that's what we saw in the distant past when we had a similar climate to today's. It's certainly not something we're going to see in the next, 100 years, 200 years, or anything like that. It's something that will potentially eventually happen. It's just when the Earth was in a similar climate in the past, that's what the ocean level was.
Yes.
So, I mean, I wouldn't make any inferences that that's what we're going to see in the next, near-term future or anything like that. It's just in the distant past, when the climate had a lot of time, we're talking millennia at the time, to sort of equilibrate to the climate at the time, that's how much sea level rise there was.
Yeah. Thanks. I'll tell you what, why don't you keep going, and I'll keep looking at questions in the
Okay.
in the chat.
Okay. So the next one is heat waves. That's an obvious consequence of global warming. You get higher temperatures, you're going to get hotter extremes. And so we'll see if this video works with the Zoom, but I just got a video. It was put together by, I think, James Hansen at NASA, where it just sort of shows the distribution of temperatures, summer temperatures between, I believe it was the 50s and today, and how it's changed. And so if it's working, you'll see it changing now, decade by decade, showing how the distribution of summer temperatures has changed. And so this gradually shifts to the right as we see global warming causing temperatures to be more and more extreme. So yeah, that's just a really clear example. It's something that I don't think anyone would dispute. As we cause temperatures to rise, we cause these more extreme temperatures and worse heat waves. So another sort of general consequence of climate change that we like to describe as is weather whiplash. And this is one that when I give my talks about California, I give some examples of that because we are kind of in the midst of a great example of weather whiplash in California. And I got this quote from a colleague of mine, Peter Glick, who's a water expert at the Pacific Institute here in California. This is from 1988. He was writing an article about California and global warming and climate change, and he said, California will get the worst of all possible worlds, more flooding in the winter and less available water in the summer. And so that's pretty much exactly what we're seeing today. I've got a couple of charts here from a paper that was looking at the recent historical drought that's kind of just ended in California, where we had this really, really extreme 4 or 5 year drought. And so basically what they did is they went around California and they took cores out of oak trees, because when you take a core out of an oak tree, you can look at the tree rings, which tell you back in time. The width of the tree ring kind of tells you how much precipitation there was in each given year. And so they went through and they reconstructed the amount of precipitation every year over the past 800 years in California, and that's what this chart is here. And the blue is sort of the most recent data, and the star is 2014 at the very right there. And so you can see 2014, and then that kind of date range, there was a low amount of precipitation in California, but it wasn't like an extreme, like there were examples in the historical record where there was less precipitation. But then they also had this second chart, which they reconstructed drought intensity. And so that's the bottom chart with the red data at the end. And so the star again is 2014. That's the last date in their study. And so you can see, while the blue star isn't at the very bottom, there are years with less precipitation, the red star is at the bottom. And so that when they put together 2012, 2013, and 2014 together, and actually the drought continued on in the years after they published their study, but 2012 to 2014 they found was the most intense drought California has had in over the past 1,000 years. And then if you add in 2015, 2016, it's even more intense. And so it's interesting that it wasn't a record low precipitation event, but it was a record intense drought event. And so basically what they determined was, what made the difference was that at the same time, we were seeing record high temperatures in California and around the globe. And so basically they estimated that because of record high temperatures, which in turn were of course caused by global warming, the drought in California was somewhere in the ballpark of 25% more intense than it would have otherwise been. And so basically it pushed a pretty bad drought into record-breaking territory. And so another example is wildfires, which is directly connected to temperatures and to drought. When you have dry conditions and you have hot conditions, it creates the conditions that are ripe for more bigger wildfires. And so this is a chart of the Western United States of large fires, which is they defined as fires of 1,000 acres or bigger in the Western United States. And you can see there's this upward trend from 1970 to 2010, where these large wildfires are just becoming more common. And so, I mean, there's various contributing factors to this. One of them, for example, is just forest management. But there has been research determining like how much of an effect humans have in this increase. And there was one paper that estimated that human-caused global warming is responsible for at least half of that increase in wildfires in the Western United States, which again makes sense because we're causing higher temperatures, we're causing more intense droughts. That's going to create the conditions for more bigger wildfires. And again, focusing a little bit on California, I've got this chart is from a study published in 2011 where they're looking at, under various different global warming scenarios, how much bigger the area burned by wildfires would become each year. And so basically anything on this chart from orange to red is at least a doubling or more of the area projected to be burned by wildfires in a given year toward the end of the 21st century as compared to the end of the 20th century. And so this is in the lots of global warming, burn lots of fossil fuels, temperatures go way up scenario. You see like basically a lot of Northern California sees a lot more and bigger wildfires. They also looked at other scenarios where we sort of curb global warming and cause less global warming. And in those scenarios, you do see an increase in wildfire area burned, but it's less of an increase, which is something you would expect. We're still going to see some global warming, but not as much. And so basically we reduce the conditions that make these wildfires more intense. But so it was sort of basically the less global warming we cause, the less worse, the less more intense wildfires will become. And so, about the end of 2016 is when California's record drought ended, but then we sort of got the other end of the spectrum. We got a whole bunch of rainfall in 2017. So that's kind of our weather whiplash, went from super intense record-breaking drought to record-breaking precipitation. And so you can see on this chart, the blue line is the precipitation falling in Northern California in the 2016 to 2017 rainy season. And so the other lines on there are sort of the previous records. The green is the record before that. in terms of total rainfall in Northern California. And so you can see basically, and then the light blue shaded area at the bottom is the average. And so you can see we were way, way above the average, and we were in fact a significant amount above the previous record amount of rainfall in Northern California in 2017. So just a little bit crazy. We went from this super intense drought to this super intense precipitation the very next year. So it's kind of classic example of weather whiplash in California. And so again, climate change is one contributor to that because, as I mentioned, as the atmosphere warms, it holds more water vapor, and so when you have these extreme precipitation events, they're just that much more extreme. And based on our physical understanding of the atmosphere, basically because of the warming we've seen over the past 50 years, there's about 5 to 10% more water vapor in the atmosphere today than there was 50 years ago, and so that basically amplifies these intense precipitation events. And so in California, one sort of consequence we saw of that was this Oroville Dam emergency that was in the news not too long ago, where basically there was so much water in Oroville Dam that it put a lot of strain on the dam, and they ended up having to use this emergency spillway, and a bunch of people had to evacuate their homes, and it was a scary event, and they were afraid the dam was going to fail, but fortunately it didn't fail. But it was just a good example of basically a strain put on our infrastructure in part by climate change, making the rainfall that much more intense. And so I went back to Peter Glick, who I quoted earlier. I talked to him in 2017, and I said, "What do you think about this?" And basically, the way he phrased it to me, he said, "Our infrastructure was designed for yesterday's climate, not today's or tomorrow's. We know the climate is changing, and we need to be prepared." So basically, the way Oroville Dam was built, it was built in the 1950s, and so it was built for a 1950s climate. And then they weren't, basically, when they built the emergency spillway and things like that, they weren't anticipating the amount of precipitation that we saw in 2017 because there was more water vapor in the atmosphere because of global warming. And so basically, it's just another factor that you have to take into account with climate change, is that because it amplifies these types of extreme weather, it puts that much more strain on our infrastructure, and our infrastructure may not have been designed with that level of strain in mind.
Hey, Dana, let me stop you for a minute and see if we've got more questions. I got a couple for you from the chat. But with respect to this, when I saw after Sandy, the New York City subways underwater,
Yeah.
I thought the exact same thing, that the infrastructure was not built for today's climate. A couple questions. Understand why hurricanes are more extreme. Why is there the possibility that there are fewer of them?
Yeah, so when hurricanes form, there's basically two big factors at play. One of them is ocean temperature. The warmer the ocean temperature is, the stronger the hurricane becomes. But a second factor is wind shear, and when there's more wind shear, it sort of disrupts the formation of the hurricane. And so it so happens that in a warmer world, you have warmer oceans, but you also have, in general, you have more wind shear. And so as a result, you get more wind shear kind of disrupts hurricane formation. And so basically our best predictions is at this point, the total number of hurricanes probably won't change very much, but we expect to see more of these Category 4 and Category 5 really extreme hurricanes because of the warmer ocean waters. So that change in wind shear is going to affect the number of hurricanes. So the number of hurricanes doesn't change despite ocean temperatures being hotter. But when they do form, they will tend to be more of these really, really intense hurricanes, and the Category 4s and Category 5s.
Good, thanks. There are a couple of questions with respect to the relationship between warming and the amount of additional water vapor in the atmosphere. Now, the question could be answered in terms of both global average temperature warming, like 1C, which is about where we're at now, how much additional water vapor. Another question, the question is also being asked in terms of ocean warming. Mm-hmm. What would a 1C warming in ocean temperature yield in terms of additional water vapor, if you know that?
Yeah, so there's this physical principle called the Clausius-Capurian relation. So I'm probably pronouncing it wrong. But
Easy for
basically,
you to say. Go ahead.
it's for every 1 degree Celsius warming you get, I think it's about a 7% increase in the amount of water vapor in the atmosphere, and that's why I said 5 to 10%, because we're at about 1 degree Celsius. So roughly speaking, you expect to see 7% increase in water vapor. And then it could also change regionally. I mean, that's sort of the global average, but then it also depends on how warm the temperature is in that location. And so that's where the ocean temperature factors in a little bit, because the warmer the ocean temperature, the more water vapor there is in the atmosphere at that point, at that time. And so it's not quite as simple as just 1 degree means 7% increase in water vapor, because it depends on local temperatures too. But that's the general rule.
Yep, gotcha. David Kane has posted, some of you have asked for a map that would provide land loss to sea level rise more globally, and David Kane has posted that in the chat, so you can go to it there. California and the drought. Do you have an estimate of the number of trees that were lost during the drought?
That I don't know.
Okay, I had heard over 100 million at one point.
Yeah, I know.
All right. I think we're going to unleash you and let you get back to it, Dana.
Okay.
Oh, I'm sorry. Let me ask, does anybody want to unmute themselves and ask a question? I think most of the questions are coming via chat.
Okay.
Let's let Dana continue then. Go ahead, buddy.
Let's move on then. So that was sort of the point I wanted to make about infrastructure. More intense climate means more strain on infrastructure. And that's also something we're seeing a little bit in Houston right now. They have some reservoirs and dams that they're worried about overtopping at this point, and they don't seem to be in danger of failing, but that's another concern, because there's just so much water, it puts that much more strain on the dams. And then, of course, snow, ice, glaciers all disappearing over time. And so the example I use, being in California, is the Sierra Snowpack, because the Sierra Snowpack is really important to California. That's like our natural water reservoir that sort of, as it melts throughout the summer, it refills our water storage systems. And so it's really important to California, but there's been research showing that for every 1 degree Celsius warming, we lose about a quarter of the Sierra Snowpack. So you can kind of see where that's going. If we get to 4 degrees Celsius, there's not going to be much snowpack left. And so, then you have to worry about where you're going to get your water from. There's also concerns about, winter sports activity and the economic productivity that brings to the region. There's all kinds of problems associated with losing snowpacks. That applies if you're in, for example, Colorado or Utah or any other region that relies on, with snow for, winter sports, or if, regions like, for example, Peru relies a lot on glacier melt for their water, and their glaciers are disappearing, and same thing in sort of the Southeast Asia and China. And so that's another concern that, depending on where you live, that's something that can directly impact a lot of people. And then general economic effects are useful to talk about. And so this chart is from a paper published, I believe it was in 2015, from some scientists at Berkeley and Stanford. And so basically what they did is looked at economic activity in different countries at different temperatures. And so basically, as you go from the bottom to the top of this chart, that's an increase in GDP. So basically, stronger economy, the higher up you go on the chart. And then from left to right, it's increase in temperature, or the average temperature of the region that the country is in. And so you can see basically at the very highest point, the peak of that curve, that's sort of the sweet spot where you're at the right temperature, that it's basically the sort of the sweet spot for economic activity, like the temperature's in the right range where it's sort of optimal for your GDP, for your economy. And so you can see there's a lot of countries labeled on here. There's a lot of European countries, US and China are on there. We're right around sort of that sweet spot, so where the climate is just like perfect for us to be having a roaring economy and good GDP and economic activity. And as you move to the right, you're moving towards hotter climate countries. And so Brazil, for example, is hotter. It's sort of tending towards that, that downward slope on that curve. A lot of sort of third world countries like Nigeria, Indonesia, sort of countries that are less economic, sort of second, third world countries, so their economies aren't as strong. They are already in sort of that region where the temperature is in their country is too hot to be in the sort of economic sweet spot of this curve. And so So there's a couple points to get from that. One is that as we warm, countries like the United States are going to start moving out of the sweet spot towards temperatures that are less than economically optimal for us. And then also as these second and third world countries warm, they're going to shift even further and further away from that temperature. It's going to impact them even more. And I have another chart from another study. This one was published in 2011, but it's got kind of the similar points, but it's also got sort of a moral, ethical component to it. And so that the top map on here is carbon emissions per capita, so per person, and red being high, blue being low. So of course you can see like these first world countries, United States, Canada, Australia, Europe. These are the countries that have a lot of carbon emissions. The blue ones are sort of poorer countries in Africa, South America, India, places like that have lower emissions. And then the bottom map shows the countries that are the most vulnerable to climate change impacts. And so again, red, in this case, red is high vulnerability, blue is low vulnerability. You can see in this case, like the richer countries are actually not so vulnerable, like the United States is sort of in the yellow range, we're not very vulnerable. Where all the red is in these poor countries, like in Africa, in the Middle East, in South America. Those are the countries that they both contribute less to the problem because they have lower carbon emissions and they're the most vulnerable to the consequences of the problem. And so there's two reasons for that. One is, we saw in the last slide, they tend to be in these hotter temperature climates already because they're near to the equator. And so they're already at that temperature where they're outside of the sweet spot. So it's sort of too hot for the optimal economic activity. And then the second reason is just they're not rich countries, so they don't have the resources to adapt to climate change as easily as a country like the United States. And so it's sort of this unfortunate moral, ethical conundrum that the countries that contribute the least to the problem are also the most vulnerable to its impacts. And obviously that's a really unfortunate thing. You know, like in an ideal world, the countries that contribute to the most of the problem will be the ones that are affected most by it. But you know, that makes it that much harder for us to address the problem because in the United States, you know, we're one of the biggest contributors to climate change, but we're not that vulnerable to its impacts. And so for that reason, it's harder to motivate Americans to want to do something about it because we don't see it as this urgent problem because we're relatively not so vulnerable to it. And so I like to make that point just because it's useful for people who are, you know, think this is something they basically grasp the moral and ethical issue. They might be more likely to be persuaded by this that we need to do something about the problem. But there are also regional changes, and so this is a similar paper. This was just published a couple weeks ago, I think, in the last week or two, where they were trying to look at how climate change will impact GDP in a regional basis in the United States. And so basically you can see red is an adverse economic impact. So basically it hurts the economy. Green is that actually benefits the economy, which, so for example, if you're in a particularly cold region, maybe warmer temperatures will benefit your economy. And so you can see like the colder regions up north, they actually, you know, make out a little bit better in terms of GDP. But the southern, sort of the southeastern United States, and probably not coincidentally, areas around the Gulf of Mexico where they're being hit by hurricanes are the ones that are going to be the hardest hit by climate. Their economies are going to be the hardest hit by climate change impacts. And so I think that's a useful thing to bear in mind, that it's not just, you know, you want to just look at it a country by country basis. It's useful to look at it in a more local terms. And so especially if you're giving presentations in that region in the southeastern United States, then this is sort of a good map to show, hey, we're the most vulnerable. Our economy is the most vulnerable to climate change impacts, so maybe we should think about doing something about it to avoid those impacts. And then I think this is my last slide, but I like to not just focus on the economy, because I think when people talk about climate change and what to do about it, the focus is almost exclusively on the economy, but there are other factors at play that we can't just put in a dollar value on. And so one of those is like biodiversity, the existence of species. And right now we are sort of on the path to Earth's 6 mass extinctions. There have been 5 previous mass extinctions where I believe it's defined as 80% of global species went extinct, something along those lines. And so we're obviously not there yet. We're sort of on that path where we're seeing a really rapid rate of extinctions as compared to what we would see in the natural background rate. And so it's a really concern that a lot of scientists have, that if this rate keeps increasing, we're on the path towards potentially a sixth mass extinction. And so this is a chart from a paper that was published fairly recently, where they were looking at the rate of extinctions over recent centuries from these various different types of animals, mammals, birds, vertebrates, and so forth. And you can see the background level at the bottom there. And so you can see we're going, over the past century in particular, we've accelerated these extinctions much faster than the natural background rate. And so, and that's not something that economists put a dollar value on, but it's definitely something that we value from just, a social sense. Like, we care about there being these other species that we can appreciate, that are still exist on the planet. It's also because we have, interconnected ecosystems. It can be a real problem. We start losing a significant number of these species. It can have significant impacts. If you want to put it back in dollar terms, it will have a significant impact on the economy if ecosystems start to collapse. But there's also inherent value in the existence of these species as well. And then, of course, in addition to putting the effects of Hurricane Harvey in dollar values, which of course there's been a lot of that, how many tens of billions of dollars is going to cost the economy, there is also, of course, the human suffering, people losing their homes, or their homes being extensively damaged by the flood, losing all of their possessions, being displaced for a long period of time. All those things basically you can sort of wrap up in the category of human suffering. And so I think that's a useful thing to keep in mind, that, the impacts of climate change don't just come down to dollar values. They also come down to other things we value. They come down to human suffering. They come down to biodiversity and other species. And so it's useful to remind people not just to think of this as a dollars and cents proposition, although, again, a lot of things written about Harvey. There was one in the New York Times today by Brett Stevens, who used to be at the Wall Street Journal, who was basically saying, in terms of GDP, on the impact on Houston, Hurricane Harvey is just like a speed bump. It's like nothing. And he was like downplaying the impacts because, from an economic perspective, it's nothing. But of course, to those people who live in that region, who are, currently lost their homes, and they have to try to, basically put their lives back together, from a suffering standpoint, it's a really big deal. And so basically, the way that argument would go is that we can just adapt to climate change, because we could just, make a bunch more money and become richer, and then we can adapt to it, and it won't hurt our GDP. And you don't worry about the suffering along with it, if you're just focused on the economy and GDP. And so it's important to remember that there are other factors besides just the dollar value. But at least with CCL, we do have the economic argument on our side too, because we have the proposal that is modestly beneficial for the economy. But nevertheless, it's good not to just focus solely on dollar values. And I think that's it. That was my last slide.
Really an amazing presentation, Dana. An enormous amount of information, and thanks all for hanging in there. Valuable. We've got the recording in case you need to go over it. I've got a question, then we'll see if others. Back to a few slides ago, if you could, with the map of America. And George, yes, I apologize. Dana was not able to fit Alaska into that. It's the lower 48 only. Can you tell us a little bit more about what the different sources of variation in GDP as a result of climate is? Clearly, warmer states do worse, cold states do better. I get that. Is there any other useful variables that are causing this?
So, unfortunately, I can't speak so much to this study, because it just came out, and actually John Abraham, my co-Guardian blogger, was the one who wrote about this. I just kind of grabbed this map from his article because I thought it was a really good, example of economic impacts on a local level, but I haven't had a chance to read the paper myself. So if you want to go to our Guardian blog, it's Climate Consensus to 97% is what the Guardian blog is called, and you can go up like a couple of, I think it was last week, was John Abraham's article about this, and he's got a link to the paper, and so you can check out the paper and read all the details about it.
Name of the site one more time, a little more slowly. I know you're.
So it's the Guardian. The blog is called Climate Consensus to 97%. Or you can just Google my name, Dana Nicitelli, and it'll pop up.
Okay. Great. Really fabulous. Okay. Edric wants to know, how does all this fit into our CCL presentations, both near term relative to Harvey, but also longer term in terms of portioning negative points and our positive CF&D solution points?
Yeah, so, I mean, I think, so there's one, like I mentioned earlier, one disconnect that people have is that they view climate change and its impact as a distant problem that's not going to affect them. And so any examples you can come up with of, you know, things that climate change is contributing to that's impacting people like here and now, it's going to help. It's going to help people realize the urgency of the problem and want to do something about it. And so, you know, if you can connect, here's the ways that climate change is making hurricanes like Harvey more intense, or, you know, if you live in an area prone to drought, here's the ways that climate change makes drought more intense, or whatever it is in your particular region. If you can connect the dots between here's how climate change is impacting you here and now in a negative way, that will make people more receptive to the solutions to the problem. And then you can go into the solutions. Here's our solution. And we have this carbon fee and dividend. It's good for the economy. You know, conservatives like it. And so at that point, once you open them up to be more receptive, then you kind of hit them with the pitch of, here's our solution to the problem. Here's why you should think it's a good idea.
You know, what I say sometimes is, look, there's a lot of major challenges facing humanity over the next several decades. You know, hunger, poverty. Here's one where there's actually a pretty damn easy fix. No kidding. And that's generally understood. And it's going to make everything else worse. So if we can get to this, let me add one other thing. And I appreciate your question, Edric. I think it's critical to give people the truth about the threat, the impacts. And I do it in a very dispassionate way. I'm not blaming anybody for it. I'm not blaming coal, not blaming oil. It's just what's so. Here, this is what we know. And here, this is a decent picture that we're pretty comfortable with respect to the threats to ourselves and to our children. I think people need to know that. And without the blame and without the, you know, we're all going to die. You know, I think you can make the point effectively. And then when you follow with that solution, you've got the potential for a really effective presentation. Thank you for that.
Yeah, so the way I structure my talks really quickly is that basically I go through the science and the impacts, and that stuff is generally pretty negative and makes people pretty worried. And I talk a little bit about the progress we've made so far, and I talk about the Paris climate agreements. Even though America pulled out of it, the rest of the world is still in the Paris climate agreement. So we're making progress. You know, carbon emissions are starting to peak. Good things are happening. And then here's our CCL solution that's going to help solve the problem even faster.
Yeah, very nice.
You ended on a positive note with CCL.
Very nice. Larry has asked twice, and he's from Texas, so we're going to forward his question. So you'd mentioned the earlier period with the 3C rise, and that I think you'd mentioned that we were at 400 points per million CO2 or CO2 equivalent. Well, CO2 probably at that point. Do you know what caused it at that period?
The temperature or the CO2 or? The
CO2, the 400 ppm.
Oh, that's a good question. I mean, it was such a long time ago. I mean, in the relatively recent past, CO2 has kind of been between 180 and 280 parts per million, so that is outside of what it's been the relatively recent period in recent history, but that was 3 million years ago. So yeah, I'm not sure at that time. There might have been a release from the oceans, for example, but I would have to go back and sort of read the research as to what caused the CO2 to be up to 400 parts per million at that time.
Okay, so that's what we got. Other questions for folks on the line? You can just unmute yourself and chime in. Okay, hearing none, I'll fill in with a Dave Kane question. So we're back to that period, I believe, and he says, I've heard that there were massive basaltic overflows in Siberia during this time that released over a long period of time massive amounts of CO2. There you go. Okay. So he's trying to answer this question. Yeah. I'd say, and I can't be helpful because I don't know what a basaltic is. So. But I bet it's a hell of a lot of fun, Dave. So okay, so for those that helps.
I can answer.
Go ahead.
And again,
Please.
it's sort of a volcanic. It's not a volcanic eruption in the sense of volcanoes, but it's
Okay.
basically overflow, and it spread out, and they call it Siberian traps.
Okay.
And they speculate that there's a massive amount of CO2 which is part of that, and it's different from the context of what we're seeing today, where it's an enormous rapid increase we're creating. This is a release over 100,000 years or so, something like that. But again, somebody needs to check it out. I'm not sure if I remember.
Gotcha. Close enough. Okay, well, thanks. Well, we're just a couple minutes to go, so let's wrap up. Todd, where is this going to be available? You've sent it to everybody probably on the listserv if you're signed up for the action team, and if you're not signed up for the presenters action team on community, please do. And this presentation should go out to you. Dana, we got to find a way to have you back, because I know you had your foot to the floor trying to get all this information in, but really valuable for people asking questions. I want to say, forward additional questions to us. Go ahead and send them to todd@citizensclimate.org, and we'll get them to Dana, and we'll try to get more. Or Dana, I suppose they could go directly to your blog, yes?
Sure. I mean, they can't ask me questions there, so questions via email are good. I have more to say about Harvey that I'm working on an article about that will be published at The Guardian next week. So if you want to check out the Guardian blog, then that's a way to keep up with the latest stuff that I'm working on.
Well, send it to us, and let's see if we can get it on the website or on community. And I mean, this stuff needs to be a resource that we can all have access to when we need it.
Sure.
What is Dana's
one more comment.
Go ahead.
What is Dana's email?
Dana's email is, go ahead, Dana.
So a good one to use is Dana, D-A-N-A, 1981, 1981 @yahoo.com. So yeah, you can send me questions there if you got any questions.
Good. With that, I think we'll sign off. I'm going to say, once again, thank you for getting out there, putting your rumps on the line, and speaking on behalf of Citizens Climate Lobby and getting this critical message out. Also, if you have topics that you want to hear on this call that you think would be supportive for yourself and others, please write to us at todd@citizensclimate.org. Todd, I have that right? Yes? Todd at
Yeah,
Citizens
that's correct. And I will publish a link to the recording of this call, and it'll be a video recording, and it'll be on community and the presenter action team in about 2 hours.
Beautimous. Thank you again, Dana. Terrific presentation. Thanks for everybody for participating. See you at the end of September.
Thanks, Dana.
Yeah, happy to do it.
Very much.
I'm gonna unmute everybody so everyone can say thank you to Dana for the fabulous presentation.
Thanks, Dana.
Thank you, Dana.
That was really great.
Really great.
Really great.
A lot of good
Go,
info.
buddy.
Thanks a lot.
Thank you.
Storm on.
The Guardian newspaper from London, and of all the places, all the newspapers in the world, the Guardian is top of the line, and we got the top one journalists.